All right, guys, we're looking at volume today. And so just sort of a quick reminder that volume is always equal to the definite integral of the area of a cross section. And we're going to stick with the dx on this. It is possible to do dy. But again, the ones we're going to do, all of them are going to be dx. So it depends on the shape of our cross section, what our area formula is. But we are going to use this, again, for everything here. So for a square, remember that our area formula is length times width or base times height, but they're the same. So it ends up just equaling base squared. Now, what our base is always going to be the top function minus the bottom function, and then it's going to be squared if it's a square. All right, sometimes the bottom function will be 0, so it's just the top function squared, but this is how we would calculate this. Notice this does not have a pi in front of it. That's going to be reserved for circles. So none of these are going to have a pi when we're talking about its cross section. All right, for the area of a rectangle, it is base times height. The base will be the same. I'm going to call it f minus g, but top function minus bottom function. So this is the base. Multiplied by the height is, we're going to be given some sort of clue as to what the height is. It might just be a number. It might just be like height is always 2. Or it might say that the height is double the base. And so I would write the base again, or instead of just writing f minus g again, I would make it a squared, potentially right there, depending on what the height is. All right, an isosceles right triangle. Our area is 1/2 times base times height, but the base and the height are the same. So here we would have 1/2 times the base squared, and the base again is always going to be the top function minus the bottom function if there is one. Again, sometimes that bottom function is 0. Okay, so these are our setups here. Again, none of these have a pi in them. Okay. Now, when do we use pi? Well, that would be when we have rotations. Okay, so if we have a rotation with one y equation, then our area, it's going to give us one circle. So our area is just going to be pi r squared. All right, and so it would look like this. You'd have pi times f of x, and that f of x would be squared. Okay, you don't have two functions here, so it's not f of x minus g of x. It's just like this. Now, if there are two y equations in a rotation, that does create two circles. And so this is our area formula. It's pi times the bigger radius squared minus pi times the smaller radius squared. Now, you can factor out pi, but what you cannot do is factor out the squared. These are always going to be separate. They're going to be squared separately and then subtracted. So the way it's going to look, again, you can factor out a pi. All right, so I'm going to write it like this. We're going to have the bigger radius squared, so I'm going to call that f of x squared, minus the smaller radius squared, g of x, which is going to be squared like that. Okay, and so this is our area formula when we have two circles. But I want to point out, this is not, like, this is the correct formula. It is not equivalent to doing this, top function minus bottom function, all being squared. Okay, we are never going to use this formula. It's never going to be pi r minus r squared. It's pi r squared minus pi r squared, or again, factor out the pi. Okay? Just like with area, be on the lookout if the top function ever changes, or the bottom function ever changes. Right, so something like this. Right, you still have to split it up into two sections, or if there's an intersection between the two top functions, right, you still have to split it up in two sections, etc. So this can still happen with volume, but again, as long as we know these formulas and we know when to use them, that's most of the questions right here. All right, so I didn't do any examples, but again, you guys will do the practice now, and then if you have any questions, again, we can go over that in class on Monday. All right, guys, stay flawless.